Hello everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. In today's lesson, we'll be looking at two concepts which are custom hooks and data fetching in React, which allow you to write cleaner, more reusable and easier to maintain code. Custom hooks allow you to extract and share logic across components, while modern data fetching patterns let you handle loading states, errors and updates in a more structured way. So in this lesson, we'll be looking at these concepts, understanding them step by step and implementing them using a practical example. So let's begin. In this lesson, we'll understand how React applications manage reusable logic and asynchronous data. We'll focus on custom hooks and data fetching and how they work together to keep components clean. So what are custom hooks? Custom hooks are reusable JavaScript functions that start with the word use. They allow us to encapsulate state and side effect logic and reuse it across multiple components. As applications grow, logic often gets repeated across components. Custom hooks exist to remove duplication and keep components focused only on rendering UI. Data fetching means communicating with an external system, such as an API or a server. This is not part of rendering the user interface. It is something that happens separately. Fetching data is a side effect because it happens after the component renders and interacts with the outside world. Side effects must be handled explicitly in React. In React, side effects are handled using useEffect. UseEffect runs after render and gives us control over when the side effect executes and how it is cleaned up. Data fetching follows a lifecycle. The component renders, the request starts, a loading state is shown, and then the request either succeeds or fails. After that, the UI updates based on the result. Tracking loading and other states allows us to give proper feedback to users. It prevents broken UI and helps handle failures gracefully. When data fetching is done directly inside components, components become cluttered, logic is repeated, and reuse becomes difficult. Custom hooks solve this by moving data fetching logic out of components. The hook manages side effects and state and exposes only the result. With this approach, responsibilities are clearly separated. The custom hook handles data, loading and errors, and the component focuses only on rendering the UI. Custom hooks help extract reusable logic. Data fetching is a controlled side effect. Separating logic from the user interface leads to cleaner, more maintainable React applications. So let us see how we can create custom hooks in React with a practical example. So in this particular code, we first start by defining the use window width custom hook. It accepts a delay parameter which defaults to 200 milliseconds. Inside the hook, we initialize a state variable called width using useState and set its initial value to window.innerWidth. This ensures the hook immediately reflects the current browser width. Next, we use useEffect to handle the resize side effect. This effect will run when the component mounts and whenever the delay value changes. Inside the effect, we declare a variable called timeout_id. This variable will store the ID of the timeout used for debouncing. We then define the handle resize function. The first step is clearing any existing timeout using clear timeout. After clearing the previous timeout, we create a new one using set timeout. When the timeout completes, we update the width state with the latest window.innerWidth. This ensures the state update happens only after resizing has paused for the specific delay. We attach the handle resize function to the Windows resize event using addEventListener. This allows the hook to respond whenever the browser window is resized. In the cleanup function returned by useEffect, we remove the resize event listener. We also clear any pending timeout to prevent memory leaks or unnecessary state updates. Finally, the hook returns the width state. Any component using useWindowWidth will now receive an updated window width value with debounced resize handling. In responsive component, we simply call useWindowWidth and store the returned value. This value is rendered directly in the UI and it updates automatically when the window is resized. So let's just run this code once. So here is my current window width. Let me extend it. So you can see the window width is being updated based on the window size. So let us understand how this particular task works. We first start by importing React and the style sheet for this component. Next, we define a constant called endpoint. This is the URL where the form data will be sent using a post request. Inside the newsletter form component, we initialize 4 state variables. Name and email store the values entered by the user. Status tracks the current state of the form. It can be idle, loading, success, or error. Error stores any error message returned during submission. It is initialized to null. The handle submit function runs when the form is submitted. We first call event.prevent default to stop the browser from reloading the page. We then set the status to loading and clear any previous error. Inside the try block, we send a post request using fetch. The request includes the HTTP method, header specifying JSON data, and a request body created using json.stringify, which sends the name and email values. After receiving the response, we convert it to JSON. If the response is not okay, we throw an error. This allows us to handle both network errors and server-side errors in one place. If the request succeeds, we update the status to success. We then clear the input fields by setting name and email back to empty strings. If an error occurs, execution moves to the catch block. Here, we set the status to error and store the error message in state. This error message is later displayed in the UI. The reset form function resets the form state. It sets the status back to idle and clears any existing error message. This function is reused for retrying submissions and subscribing again. If the status is success, we return early and render a success message. The user is shown a confirmation message along with a button to reset the form. If the submission is not successful yet, we render the form. Each input field is a controlled input. Its value comes from state, and onChange updates that state. Inputs and the submit button are disabled while the form is in the loading state. The submit button conditionally displays text based on the current status. While loading, a spinner and sending text are shown. Otherwise, the button displays subscribe. Now if the status is error, an error message is displayed below the form, and a retry button allows the user to reset the form and try again. Finally, we export the newsletter form component so it can be used elsewhere in the application. Let's just run this code once. So you can see we were able to successfully submit the form. So that wraps up our introduction to custom hooks and data fetching in React. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson, and I will see you in the next one. Thank you.